degrees phase shift between the 1U firing angle and the 3U firing angle, or like 120 degrees phase shift between B and C. Okay, so here again, we keep the switch on for half a cycle and then it would be off for the other half. And the same thing that we did for phase A and B, it's going to be also valid for phase C. The lower level switch would be just complementary of that. When this is on, this is off, and this is off, this is on. Okay, so this is what we end up with for the gating signals that we supply to the switches. Okay, if we do that, now let's take a look at phase voltages. So I mean like VAN, VBN, and VCN, right? I divided the period to 6 different periods, small periods, and you can take a look at the first period here. In the first period, we have 1U on, 2U is off, and 3U is on. So we would have 1, 0, 1. So we would be in this state, right? So 1U is on, 2U is off. It means that 2L is on, and 3U is on. So that's what we end up here in the first, in the first period, in the first out of the 6 like sub periods that we have. Let me call it sub period. So here VAN, it's gonna be VD over 2. VBN, it's gonna be negative VD over 2. And VCN, it's gonna be positive VD over 2. Okay, let's just like focus on the phase voltages first. And we move on. Then the second sub period, we have 1U on, 2U is off, so 1, 0, and 3U is also off, so it would be 1, 0, 0. So we are in this state. So it means that the voltage of phase N is going to be still VD over 2. Voltage of phase B, it's going to be negative VD over 2, and voltage of phase C is also negative VD over 2. And we're going to continue this. So again, like let me look at this sub period. Basically it's going to be the fourth sub period. So 1U is off, so this is 0, 2U is on, this is 1, and 3U is also 0, so it would be 0, 1, 0. So we are here, and if I look at this period here, I draw this because this is 0, it's going to be negative VD over 2, this is 1, it's going to be positive, this is 0, it's going to be negative, right? So we end up with the phase voltages, and if you look at it, you would see that for these phase voltages, excuse me, again, they're going to be equal to VD over 2 for half of the period and equal to negative VD over 2 for the other half. And they have that 120 degrees phase shift that we wanted to have between phases, right? So this transition between negative VD over 2 to positive VD over 2 for phase B happens 120 degrees or 2T over 3 time after, like 2T over 3 if we are like looking at the time after the same thing happening for phase A. And the same thing happens for phase C, 240 degrees after it happened for phase A, or like 120 degrees after it happened for phase B. Okay. Now what we want to look at is line to line voltages. Line to line voltages, it's going to be VAB, VAC, and VBC. So let's draw that, right? And I can say that VAB, it's going to be equal to voltage of phase A compared to versus neutral minus voltage of phase B versus neutral, right? So to draw VAB, I just need to subtract this signal from here, right? So for the first period, VAB becomes VD over 2 minus negative VD over 2. So it's going to be positive VD. For this one, again, it's positive VD. For this one, both VAN and VBN are equal to VD over 2. So if I subtract them, it becomes 0. And then later on becomes negative VD over 2 minus VD over 2 becomes negative VD. And again, here it's going to be negative VD and eventually becomes 0 again. And this keeps going. So the same thing happens again. It's periodic signal, so that happens again. And the same thing for VAC and VBC. Okay, so what we end up here again, we'll see that here for VAC, this is going to be voltage of phase A minus voltage of phase C. So it's going to be this voltage minus this voltage. It's 0 here. This voltage minus this voltage. So it's going to be VD over 2 minus negative VD over 2. It's going to be positive VD. Positive VD becomes 0. And it would keep going. The same scenario for voltage of phase BC. The line to line voltage for BC. And again, if you look at this, we'll see that we have a periodic pulse width modulated signal, square wave signal, that these three PWM signals, these three modulated signals, they have a phase shift, like 120 degrees, 60 degrees phase shift, and it just like it continues, right? So let's now basically see what happens when we have VD over 2 at VAB. For here, like when VAN is VD over 2 and VBN is negative VD over 2. So it means that this switch is on, this is off, this switch is on, and this switch is off, right? So we would have like basically a current going through the phase here, through this switch and through this switch. Okay, and this is going to be our line-to-line voltages, and that's exactly what we want. We want to have line-to-line voltages. The phase voltages are 120 degrees apart from each other, and we have the line-to-line voltages. Now, because we are subtracting phase voltages, we get 3 levels for our line-to-line voltages. We get VD and 0 and negative VD. While for our phase voltages, because this is similar to, because this is basically a half bridge for each phase, we only have 2 states, VD over 2 and negative VD over 2. Okay, so this was the case when we had only 1 pulse per period, right? So 1 pulse per period. Basically, the frequency of the switching is 1, right? And we ended up with this AC signal that